Hello everyone, my name is Anchal Thaman. Me and my partner Dwayne Vaz have together created the TACD PPT, and we worked on the document a research paper measuring document similarity using finite state automata. So the overview of this topic is that in this paper, basically the similarity between a pair of text documents will be measured. And we'll be doing that by using three sets of words. First, that that exist in one paper but do not exist in the second. The words that exist in both the papers, and the words that exist in the second but do not exist in the first. So, two deterministic finite automata are built to recognize the words of the two documents. These finite state automata used to identify three sets of words. An experimental study was also conducted for the same, and we used the approaches Jaccard and cosine distance for the same. Three test cases were also used, and the proposed approach gave more reasonable results than Jaccard, but more inflated than cosine distance approach. Given the two text documents, D1 and D2, we will quantitatively measure the similarity of these two documents. Our approach will be done on identifying three sets of words. Like I said, first, D1 minus D2, which is basically words existing in D1 but not in D2. Second is D1 intersection of D2, words existing in D1 but and in D2. Third is words existing in D2 but not in D1, which is D2 minus D1. So the notion of set used here differs from the concept of mathematical set. Word repetition is allowed in all our sets. This is justified because a higher frequency of a word means that it is more important and more related to the context of the document. I now hand it over to Dwayne.
All right, so our approach. Our approach is based on building two deterministic finite state automata to recognize the words of D1 and D2. These two DFAs are then used to identify the three sets of words stated before. These sets are also used to give quantitative measures for the similarity between these two documents. And the two approaches which are given in the paper are Jacob's similarity measure and cosine similarity measure. In this paper, the approach followed by us differs slightly from the Jacob similarity measure, which is explained in the next slide. So, Jacob similarity measure, it's a well-known measure for similarity between sets, and in this generic measure, the similarity between these two sets is found by finding the ratio of the size of the intersection to the size of the union. In this approach, a text document is viewed as a set words where repetitions does not count. Our approach is very similar to this approach. Our approach differs than this approach in that in addition to the percentage of the words in the intersection to the total number of words in both documents, another two measures are considered, that being the percentage of words in D1 and not in D2, and the percentage of words in D2 but not in D1, basically minus. In the proposed approach, both word frequencies are considered in measuring three sets of words. These sets accept word repetition. In the proposed approach, the documents are cleaned from common and less context-sensitive words. Cosine similarity measure. This measure may be used to measure the similarity between two text documents by viewing each document as a vector. And then we can find the distance between these two vectors. Unlike Jacob's approach, this approach considers word frequencies. It is to be applied on text documents, where a text document is converted into a vector by counting the frequencies of each word in each document. And each document will be modeled as a vector whose length equals to the number of distinct words in both documents. The coordinates of the vector will be the frequencies of words that exist in either document. The two vectors are then normalized by dividing the coordinates by the square root of the sum of the squares of the coordinates of each vector. The cosine distance is measured by finding the dot product of those two normalized vectors. The advantage is that it considers the frequencies of the words in measuring similarity. The disadvantage is that it needs more computation. So our proposed algorithm is that we take two text documents D1 and D2 as inputs, and the documents can be of file formats such as PDFs or doc, and they need to be first converted into text file using special converters. Uh, then we next build text strings for each of the files and clean them so that they only contain words. In the cleaning process, punctuation marks are excluded and very common words that do not reflect knowledge about the context are also removed. Next, two DFAs that recognize the words for each of the two strings will be built. And after that, both text strings are combined into one string, D combined. So to explain this algorithm, what we are doing is we're first, as I mentioned before, this is the flowchart for the same thing where we are cleaning D1 and D2 and we're building two DFAs. And D combined is the concatenation of D1 and D2. Next, we first get the next word W from D combined, and if W is recognized by DFA1 and it is recognized by DFA2, then we add it to D1 intersect D2. If it is recognized by DFA1 but not recognized by DFA2, then we add it to D1 minus D2. And if it's recognized by DFA1, no, and yes, if it's not recognized by DFA1, then we just add it to D2 minus D1. If there are more words in D combined, then we go and start back at where we get the next word from D combined. And if not, then we generate statistics. So we had mentioned in the previous slide how we are building DFAs. And this is the algorithm for that. Basically, the current state is the start state of the DFA. Then we get the next word, W from D. Then we get the next letter, L from W. And the next state is basically like the transition between current state and I. And if the next state is null, then we create a new state and we then we add a new transition from the current state to the new state labeled with L. And we make it so that the current state is equal to the new state. And then we check if L is the last letter of W. Or if the next state is not equal to null, then we directly check if L is the last letter of W. If it's not the last letter of W, then we start again at get the next letter L of W. If it is if it is the last letter of W, then we set the current state to be the final state. And if there are more words in D, then we start again to get the next word W from D. If not, then we are done. So this is the DFA for D. This is what it looks like. And we have also mentioned that final states are distinguished with a different color. So this is another algorithm which was mentioned in the first algorithm which we had shown, where and basically we make it so that the current state is the start state of the DFA, and it's very similar to the previous algorithm which we had mentioned, but it's kind of different. And so we get the next letter L of W. Then we make it so that the next state is a transition between current state and L, and we check if the next state is null. If it is null, then W does not belong to D. If it is not null, then we make it so that the current state is the next state. And then we check if L is the last letter of W. If it is the last letter of W, then we make it so that the current state is the final state. If it's not the last letter of W, then we make it so that then we just get the next letter L of W. As I mentioned before, is we then check if the current state is the final state. If it's not the final state, then we just mentioned that W does not belong to D. If it is the final state, then W belongs to D.
Okay, so now I'll talk about the experimental studies that we've done. So we've taken basically three test cases. The paper that is chosen in the first test case is both with Arabic language documents. So we have chosen to find the similarity between two well-known Quran interpretation books, and you can see here that the size before cleaning is about 2,800 to 1,100, and after cleaning, basically removing all the punctuation marks and stuff, it reduces. Then we find out d1 minus d2, d1 intersect d2, and d2 minus d1. You can see the percentages here. The next test case that we took is two less similar documents but with close contexts. So we basically choose D1 to be Tariq Tabari, which is a Islamic history book, and D2 to be Tafsir Ibn Kathir. So here you can see that the percentages are basically more for D1 minus D2, D1 intersect D2, and D2 minus D1. The third test case that we took is comparing two documents which are completely different contexts. So the first one is the Khalij 2004 corpus, and the second is the Tasfir Ibn Kathir. And these two are basically different in the sense that the second is composed of articles of a newspaper with four different categories of news: international, local, sports, and economy. Here also the percentages are different than the previous test cases. So to compare all our work with these approaches, Jacquard similarity measure and cosine distance were computed for the same pairs of documents tested above. So for the first test case, you can see that Jacquard is 18% and cosine is 79%. So this basically relates to our proposed approach of 91.94, and the documents are thus very close. The second test case, whereas, has Jacquard of 10% and cosine of 72%. Therefore, our proposed approach ka percentage decreases and the documents are close. The third test case has 66.7% of proposed approach. Therefore, the document contexts are very different. To present the different scenarios of these three values, we use qualitative values which are showed in the table below. These values are small and high. Among the 8 possible combinations that we have of small and large, we only have 6 possible combinations, which are D1 is similar to D2, D1 is generic to D2, D1 is not similar to D2, D1 is generic to D2, and D1 is not similar to D2. The conclusion of this paper is that in this paper, a finite state automata approach was used to quantitatively measure the similarity between a pair of text documents by finding the percentages of three sets of words. Our approach showed a relatively closer result to cosine distance approach than Jacquard approach. The three-valued measure of the proposed approach gives additional information about the document similarity more than the single-valued measures. For a future scope, we have that it would be interesting to consider only words with high frequencies in measuring the similarity and to see if that gives more convincing results. These are the references that we use for this paper. Thank you.